Thanks very much. So I'm Gonzalez Quiros, hydrogeologist at the BGS, and I'll show you some hydraulic and thermal responses from one of the tests we ran for 25 days at the observatory last November and December. So this test was abstraction in GJ07, so you can see that with the red arrow, 6 liters per second, heat abstraction, so remove of around 3.5 degrees, and rejection in GJ01. All in the same mine working. So the objective here, so this is not like the typical configuration for a mine water commercial scheme. So the objective here is to create a thermal plume to try to understand better the system, so like a thermal tracer test. So these are some of the hydraulic responses in the mine working boreholes. Both graphs, top and bottom, are the same in terms of the groundwater levels. And the upper graph is with the barometric pressure and the bottom one with the rain. But there are three things to consider here just very quickly. So first we can see the Glasgow main boreholes that you can see at the top in kind of green, blue light colors are almost the same levels and they are higher. So this corresponds to the deeper mine levels. So the water in the deeper mine levels is higher than in the shallower mine levels. So we have an upwards hydraulic gradient. This also shows that there is very good connectivity in the same mine working. However, there is a limited connectivity between the two mine levels, the upper and the Glasgow main. So this is important to characterize the system, and as we discussed yesterday, for the hydrogeological conceptual model. And also you can see some natural fluctuations in responses to the barometric pressure. That is inverted relationship between the changes in the natural fluctuation in the groundwater levels and the barometric pressure. This is normal in confined aquifers. And also some variations after episodes of rain. So this is 10 minutes rain data in the blue bars in the bottom graph. And lastly, you can see in the Glasgow upper lines that you can see the abstraction well is the yellow line. So there is a decrease in the level, and also an increase in GJ01, which is the reinjection borehole. And you can see that the same hydraulic characteristics, it should be like the same one. The changes. However, this shows the injection area or the injection hydraulic properties around the GJ01 are higher transmissivity, so the changes in the groundwater levels are lower. This is some temperature data from the abstraction and rejection boreholes. You can see in the purple and red lines, this is from GJ07. So you can see that the lines are slightly different. So if you see the purple line is from the wellhead, so it's the water coming up through the pump into the pipes. So the sensor is at the surface. And the red line is the hydrologger sensor that sits above the pump. And you can see the responses are slightly different. And this is because the water is coming up from the mine through the pump and into the pipe. However, the logger that sits above, there is some processes of recirculation there. So this shows that it is important when you design your monitoring network, what you're measuring, and there are different responses. And you can see are quite stable over the length of the experiment. There's slightly decrease at the end, but it's very, very constant around 11.9 degrees Celsius. And you cannot see anything now. And now you see some blue lines, light and dark blue lines that are injection wells. So now the logger sits below the mine hole, the injection main. So it fluctuates. You will see why in the one of the next slides from the data from the surface infrastructure, but it varies around 8.9 degrees Celsius. So this change around 3.5 degrees of heat abstraction in the infrastructure. This is some data from the DTS cable. So this is data from the GJ01 that is here and GJ02 that is 10 meters from the injection well. So you can see the change in the temperature over time. You see the more like the blue colors is colder, and you can see the level of the Glasgow upper where the screen interval is. So is the water flowing into the mine and is getting colder around 8.59 degrees. And when the experiment stops, you can see more green and yellow colors. There is some kind of recovery of the temperatures around the well. And in the bottom graph, you can see the graph from the GJ02. So you can see the thermal plume also arriving at the level of the Glasgow upper depth, some kind of blue colors there. You can see that after 2-3 days, the thermal plume arriving. And at the right, you have some data at the screen or at the depths of the the mine upper of the Glasgow upper level, some points. So you can see at the bottom the blue line is very constant, so it's the injection during the experiment, and then the recovery in the purple line, and the other the yellow and the green is from GGO2 at the level of the mine working. So we can use this data. So my colleague Milan, she's got a very nice poster upstairs. We're trying to use this data to try to estimate the properties and the thermal properties of the different lithologies, because you can see some bands of blue, green, so it's related to the lithologies of the site. And finally, some data about the geothermal infrastructure. So first, you can see here the mine water circuit. So again, you see the orange and purple is the water coming out from GGO7 into the heat exchanger. So that's the purple line. Then the heat is transferred to the secondary loop, and then it's reinjected. So we have the green line, which is out of the heat exchanger and reinjected into GGO1 in blue. Here we have the other side of the heat exchanger, so the temperature in the secondary loop that increases from the light blue into the red. And finally, the data from the other parts of the secondary loop in the heat pump in yellow and light blue.